Hello and welcome to Mr. Castillo's lesson on color part 2 of 3. In this lesson we're going to discuss how the eye sees color and the physics of color. So let's move on. So before we go on, let's take a little quiz. Do you know another word for color? It is hue. Which are the primary colors? These are red, yellow, and blue. So that makes orange, green, and purple the secondary colors. A color wheel is good for organizing colors. It is an organizing tool. Do you remember what a tint is? A tint is any hue that you add white or light to it. And a shade is any hue that you add black or dark to it. Alright, so the physics of color, how we see color. As you can see on the left, the picture with color is much more vibrant and stands out than the picture on the right, which makes the colors dull and boring. So, colors make works of art fun and stand out. Now, you should check out Neil Harbison's TED Talk, in which he discusses his color blindness and how he's able to listen to color by the device on top of his head, which technically makes him a cyborg. Here is the link. It takes you directly to the TED Talk and play it, and it's short, 10-minute video, but it's very fun and interesting to listen to because he's also an artist and makes works of art based on the sounds he hears. Alright, moving on. Here's the intro of the TED Talk, but we're not going to play it here. So, how we see color. Color is an element of art that is derived from reflective light. We see color because of the light waves that reflect from objects to your eyes. White light from the sun is in actuality a combination of all colors. So, white light enters the prism, and as you can see, all the colors are divided individually. And these are the colors we can see with our human eyes. There are other rays that are invisible to us. Can you think of any? Well, these could be X-rays and gamma rays. We know they're out there, but we can't see them. Here's a beautiful picture of a rainbow I took on a trip down to Mexico, and here it was very close to Monterrey, and that's the closest I have ever been to the rainbow. But I saw it and I thought it was a good picture for this lesson on how the water acts as a prism and divides the white light from the sun. Thus we can see the rainbow. So objects absorb some waves of light and reflect others. For example, here in the red apple, the white sun sends all the colors in a white beam of light, but then the apple absorbs all the colors and only reflects the red one. Here is a cross-section of the human eye and how objects and colors enter the eye and are actually sent upside down, but our brain puts them upside right again. Now, the colors don't change, but your ability to distinguish them does. Think of people with color blindness. Think of animals with extreme vision, such as eagles, and animals with limited vision, such as those nocturnal animals. You can be fooled, yet the color is always there. Now, but before we go on to an activity, I will want you to take a blind test. You follow the link below and it will take you to a page by enchroma.com, which sell these really cool glasses that's supposed to make you see colors, and you take a short little test and it will show you some numbers and you're supposed to click on the color, on the number you see on it. And as you can see, you can take this test as fast or as slow as you can. I'm gonna go really fast. If you can see the number, I can see the number 9. I can see the number 9 again, the number 9 again. It's supposed to test all the types of color blindness you might have. Now, like I said, there are different types of color blindness ranging from mild to extreme. And mild, you might not be able to see some sorts of red colors. An extreme could be that either you see the world in complete black and white, and this is due to layers of color receptors in your eyes that pick up colors. You may have them damaged, or you might actually be missing one or two. And if you're missing some, then it'll make you partially colorblind. You may be able to see some colors of the color wheels good, but not the rest. You should look up more on color blindness. It is very interesting. And as you can see, I have normal color vision. You should do your test to see if you have normal color vision. Otherwise, you might be interested in, getting some of their glasses. But they are quite expensive. Here's a video of an older gentleman getting one of these glasses, and I want to show you his reaction as he puts glasses for the first time. There we go. And as you can see, his emotions take the better of him. So this is what they did. They started showing these little videos as a way to promote their product. I find it very interesting and very emotional to see somebody being able to watch color for the first time. Alright, very emotional. Alright, we're going to conduct a little experiment right here with my document camera. And the purpose is to identify colors. Now, 5 suspects got away in 5 different cars. And you are going to be able to tell the color of their cars based on the light reflected. Alright, so here we go. Oops. Alright, well, here we go. So, here is color of suspect number 1. Ooh. Can you tell what color this is? Alright. Here is a car of suspect number 2. Can you able to tell what color this is? Suspect number 3. What color is that? I don't know, guys, but they all look orange to me so far. What color is that? And finally, car number 5. What color is this? All right. Now we're gonna move on to blue light and see if we can see the same colors we saw under the red light. Oops. Right, well, here's car number 1 again. Oh, now it changes. I see, and I don't know, if it were me seeing for the first time, I would say this is a violet car. Car number 2. I don't know, looks orange to me. Car number 3. Uh-oh, this also looks orange to me. And card number 4, this looks green. And card number 5, well, this looks blue to me. All right, so let's see what they actually reveal under the white light. All right, card number 1 is actually red. Card number 2 is actually yellow. Card number 3 is orange. There you go, orange. Card number 4 is actually green. Looks a little bit yellow here, but it's actually green. There you go, it's green. And card number 5, well, that was blue. Well, I hope you got your colors. All right, well, I hope you're able to tell the police the right colors of those cars, because I was full under the red light. All right, so let's have another experiment. And I want you to stare at the dot for about 20 seconds. Are you staring at the dot? Here I go. 5, 4, 3, 2, 1. Did you see that? Play it again if you didn't see it. Well, what you were supposed to see was the after image. It occurs because the receptors in your eyes retain the visual stimulation even after it has ceased. The after image is the opposite or complementary of that color. The after image is ghostly. You can use this to your advantage once you've learned more about the properties, which are hue, value, and intensity. Let's check another one. Stare at the dot, okay? Stare at the dot for a few seconds, and then we're gonna change to see who it is and what color her hair is. Now, this also works when your eyes are lying on your bed in your room, and you stare at the white light bulb directly above you, and then you look away and you see this black spot. Well, that is also the after image. It also works that way. So your eyes are constantly being stressed out, wanting to see the opposite. Here we go. 5, 4, 3, 2, 1. Oh, were you able to tell who that was? What color her hair was? Here we go. Here's the reveal. It is actually Demi Lovato with her reddish hair. One more. Go todos. Stare at it for a few seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, did you see that? The only colors that did not change were the gray colors, because grays are neutral. The gray colors actually stay the same. The only colors that changed were the blue to the opposite, which was like a yellowy orange. And here is just plain old color. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What color did you see? It was supposed to be like a red orange. All right, so the color activity will be to paint these fruits with their original color, but instead of adding black to make shadow, we're going to use its complementary. So in order to make the shadow for the yellow bananas, what is the opposite of yellow? Do you remember? Look at the color wheel. The opposite of yellow is violet. So we're going to use some violet to make the shadows on the banana. On the red apple, what is the opposite of red in the color wheel? It is green. So we're going to use some green to make shadow. And the orange, what is the opposite of orange in the color wheel? Blue. So we're gonna make some orange and blue to make some brown, and add the shadow. Okay, here's an example of a picture of a banana, so you're reminded what bananas look like. And when you mix yellow and violet, you're supposed to get this sort of brown, okay? Because even browns tend to be different. All right, well, this concludes the end of part 2. Make sure you come back for part 3 of 3. Thank you. Goodbye.